Hello student, today I am going to continue from the last class. Last class I was discussing I have discussed some numericals based on electrochemistry. Now other numericals I will continue. And last class I have discussed some basic concept also regarding electrochemistry. Here you should know that what actually you are studying in electrochemistry. Already I have discussed in details in the previous classes, but now just I want to repeat. Here in electrochemistry you are studying that conversion of energy. Chemical energy is converted to electrical energy, and electrical energy is converted to chemical energy. Then actually these things are studied mainly, other things are also there, but this conversion of chemical energy to electrical energy and electrical energy to chemical energy, that you are studying here. Then here you will find two types of cell. First cell is actually this comes under the electrochemical cells. Then here two types of cells you are using. First cell, that is the galvanic cell or voltaic cell. This is the one type. And second type is electrolytic cell. Then in galvanic cell or voltaic cell, chemical energy is converted to electrical energy. Means it is a device. Cell is a device to convert chemical energy into electrical energy. Then this is done through galvanic cell or voltaic cell. And second, now reverse case, here by the use of electrical energy, chemical reaction is going to be started. Okay, means chemical energy, electrical energy, by the use of electrical energy, chemical reaction is just carried on. Then these two type of cell, means galvanic cell or voltaic cell, first type, and second type, that is electrolytic cell, both comes under the electrochemical cell. Now here what are the reactions involved? Study means last class I have discussed by just solving some numericals. Now other numericals I will solve. Then now here you can see today's first numericals I am going to solve, that is this calculation. You have to calculate the electrode potential of a zinc electrode dipped in a solution of 0.05 m ZnSO4, in which the degree of dissociation of ZnSO4 is 0.6 at 298 Kelvin. A standard electrode potential of zinc electrode is given, that is the minus 0.76 volt. You have to calculate electrode potential of zinc electrode. You have to calculate. For that purpose, it is given here. This electrode is dipped in a solution of electrode, means zinc electrode is dipped in the solution of 0.05 m ZnSO4. Correct? Zinc is dipped in this solution 0.05 m ZnSO4, in which degree of dissociation, it is important, degree of dissociation of zinc sulfate is 0.6 at 298 Kelvin. Means it is not 100% ionized. zinc sulfate is not 100% ionized, it is only just 0.6%. Okay, dissociation is there. Temperature is at 298 Kelvin. And standard electrode potential is given minus 0.76 volt. Then how will you calculate electrode potential of zinc? Then for that, first you have to write the, you can say, reaction. Standard, here just to see, standard electrode reaction. Standard electrode reaction is this first. This is the reduction. This is the reduction. Okay. Zn plus 2E. It is given Zn. Okay. This is a reduction reaction. And now concentration of ZnSO4 is given 0.05 m. Degree of dissociation is given ZnSO4, that is degree of dissociation of ZnSO4 is 0.6. Then what will be the actually concentration? Then concentration will be degree of this concentration of zinc ion, because it is not 100%. It is only 0.6%. Just degree of dissociation is 0.6. Hence, just to multiply it, 0.05 is the concentration into 0.6. Then real concentration is 0.03 m. Concentration of zinc ion is actually 0.03 m, not the 0.05, because dissociation is only 0.6. So now actual concentration is 0.03 m. Correct? Standard electrode potential is given this minus 0.676 volt at 298 Kelvin. And here you can see two electrons are involved in this reaction. Here n is equal to 2. N is equal to 2. Then now it is very easy to calculate electrode potential. Now easily you can calculate at 298 Kelvin electrode potential, that is represented by E. That is now by using the Nernst equation. Nernst equation, that is this E is equal to a standard electrode potential plus 0.0591 divided by n log Zn plus means concentration of molar concentration of zinc ion. This is the Nernst equation for electrode potential. Actually, this Nernst equation is for cell also, for the EMF of the cell, and for electrode potential also. You can calculate both electrode potential also and E cell also. Then now here you are using calculating electrode potential. As per question, you have to calculate electrode potential. Already last class I have discussed why it is becoming plus. Actually it should be minus, but here it will be, what will happen, Zn ion plus Zn. That time it will be minus, but now you have reversed it. That's why plus became minus became plus, because this is reversed. This is reversed. Metal divided by metal ion. Correct? That is a correct. If you write this reaction, then in that situation Zn will go up and Zn ion will be down. Product divided by reactant. But if you reverse, then sign will change. Minus will become plus. After that, nothing is there. All things you are knowing that. Just you put the value of all. A standard electrode potential is given. You have put 0.0591 divided by n. N is equal to 2. And log base 10. This zinc ion concentration is given 0.03. Then easily you can solve it. And here you should know how 0.0591 came. That you should know. that this is the, if you will put in Nernst equation, R value will put, T value will put, means 223 plus 25, 298, correct? 2.303 RT, NF is there. Then except N, all value will put R value 8.31 joule per Kelvin per mole, and T is equal to the 298 at 25 degree. F is equal to 96,500 Coulomb. Then only N value you have to write. Then after solving all the things without N, you will get 0.0591. Okay. Then here N is equal to 2, number of electron taking part in the reaction. Then after putting all, you will get that value will get minus 0.805 volt. It is easy to solve it. 0.03 means 3 divided by 100. 3 divided by 100 means 3 into 10 to the power minus 3. Then here not 0.032, 100. 3 divided by 100 means 3 into 10 to the power minus 2. Then minus 2 will come here, then become plus minus minus. Here that minus will come here, then it will become minus 10 to the power minus this 3 into 10 to the power minus 2. Then minus and this plus, it will become minus, correct? And here that this 2 and 2 will cancel. Here 10 to the power minus 2, then minus 2 means this 2 and this 2 will cancel. It will become minus. After that what is remaining? Just log 3 value you have to put. Log 3 value you have to put and just to multiply. You will get here, final result you will get 0.805 volt minus 0.805 volt. Correct? I think now this is clear. One numericals you have solved. Now I am going to discuss second numericals. Calculate the EMF of a cadmium copper cell in which cadmium is in contact with 0.002 m cadmium sulfate and copper is in contact with 0.02 m copper sulfate solution. The standard EMF of the cell is given 0.74 volt at 298 Kelvin. You have to calculate EMF of a cadmium copper cell. Correct? You have to understand the question, only then you can solve. You have to calculate EMF of the cadmium copper cell in which what they have given, cadmium is in contact with 0.002 m cadmium sulfate and copper in contact with 0.02 m copper sulfate solution. The standard EMF of the cell is given 0.74 volt at 298 Kelvin. Then this reaction is not very tough. If your concept is clear, you can solve it. Here first you write cell reaction. Cell reaction you have to write. Only then you can solve it. Then cell reaction. Actually half cell reaction. For both you have to write. And then you have to add it. Then you will get this reaction. This reaction, cadmium plus copper, and this is a final reaction. Cell reaction. Half cell plus half cell. If you write separately for cadmium will give oxidation process step. Cadmium will give cadmium ion plus 2 electron, and copper will take Cu2 plus 2 electron, it will convert copper. If you will add electron, electron will be cancelled. What is the remaining? You can, if you write, then you will get this. This reaction you will get. After that, what you have to do? Here, copper concentration is given. Concentration of copper is given 0.02 m. Copper ion concentration. Cadmium ion concentration is given 0.002 m. And standard electrode potential is given 0.74 volt. Okay. Cell EMF is given. Cell. Okay. The standard EMF of the cell is given 0.74 volt. Standard value is given. Standard, remember it. Then now after that, just to write the, you can say, this Nernst equation. Nernst equation you have to write. Then at 298 Kelvin, EMF of the cell, this formula you know, that is the Nernst equation. E is equal to E naught cell, standard 0.0591 divided by N log. Concentration of, you can see, product divided by reactant. Then product is cadmium ion plus copper. Concentration of, molar concentration of cadmium ion plus molar concentration of copper divided by reactant. Molar concentration of cadmium and molar concentration of copper ion. Actually, this big bracket is known as molar concentration. Then now all things you are knowing. Cadmium value is given 0.002 m. Here that value you have to write 0.002. And copper and cadmium, here is very, very important. Copper and cadmium both are solid metal. Hence its activity or molar concentration will be unity, means 1. Here copper is equal to 1, cadmium is equal to 1. Then main is cadmium ion and copper ion. And copper ion value is also given 0.02 m. Then N value is 2. N value is 2. Then now we put all value, and E standard is given. Standard E is given 0.074 volt. Then you write here this. Here you have written 0.074 volt. E standard. After that minus N value you have written that 0.002 for cadmium ion and for copper ion 0.02. After solving all the things, it is very easy to solve. Down will be 30, upside will be 20. Only one 10 will be remaining, log 10, that is equal to 1. Correct? Now 3 digit upside, 3 0 will be down, 20 will be up. Means 10 to the power minus 1, 0.1. You will get log 0.1. Means 1 upon 10. Means 10 to the power minus 1. Then minus will become plus. Here value we have put, E standard value we have put here, and this N is equal to 2. N is equal to 2. Then this divided by 2, you will get this value. Correct? After dividing, half of this is this. Log 0.1, I told you, 10 to the power minus 1, it will come plus. And this add both, you will get this final answer. Correct? See, first numericals, this was the new. Degree of dissociation was new. Correct? That was due to this you can say degree of dissociation, this numerical was important. In second question, this is here you have to understand that molar concentration of this is one, first thing, and second things you have to write cell reaction. After writing cell reaction only you can solve these numericals. After that all value is given. You have simply have to put the value, you will get the result. Now next this numericals I am going to solve. This is very, very interesting and here you have to apply your special mind. Okay, and first you read the question, then you will understand what is the problem here. The standard reduction potential, that is E standard, for the half cells are as zinc, means this is the half cell reaction. It is given in question. Zn, that is the oxidation process. Its value is given 0.76 volt, and for iron is the given Fe is converting to Fe2 plus 2 electron. Its value is given 0.41 volt. Correct? For the both half reaction, E standard is given. E standard is given for the both. Okay, the standard reduction potential, standard E0 for the half cell reaction. For this reaction Zn2 plus, it is given 0.76 volt, and for iron, another half cell reaction, its value is 0.41 volt. Calculate the EMF of the cell reaction. This is the cell reaction, it is given in the question. Then you will think that all values are there, you can calculate, you will think like that, but it is not so easy. Correct? Here you can see the standard reduction potential value is given. You should understand zinc. When zinc will convert to zinc ion plus 2 electron, this is the oxidation actually. This process is oxidation, you know. Then actually its a reduction potential in real sense should be minus 0.76 volt. Minus, not the plus. But it is written 0.76 volt, means plus. It is given in question. And here ferrous is converting to ferrous ion. This is also oxidation process. This is also oxidation. Then now you can see for that also its reduction potential is given 0.41 volt. Then see, in any cell reaction, one should be oxidation and other should be reduction. Correct? Both processes required, oxidation as well as reduction. Both processes are compulsory, otherwise there will be no reaction. You know, oxidation and reduction takes place simultaneously, just at a time. That here it is a given, only oxidation reaction is given for both. For zinc also oxidation, for ferrous also oxidation. This is actually things you have to see, you have to consider. You have to convert it into the oxidation and reduction. Oxidation and reduction reaction. Then now for that, here how will you solve? EMF you have to calculate. Then you know, already I have discussed that E cell is equal to E cathode minus E anode. Correct? This is a standard formula. E cell is equal to E cathode minus E anode. Means you can say right hand electrode. E of right hand electrode minus E of left hand electrode. Correct? Then you will use only this formula. Other concept is also there. That I have written. That here a standard E cell. This way also you can solve it. That is the electrode potential of oxidation process for Fe and reduction for Zn. This way also you can solve it. Oxidation as well as reduction process. Here also two process you are considering. Here it is not given which is actually oxidation step. Only oxidation step is given, but which electrode you will use as cathode or anode, it is not clear. This is important here. Here, how can you tell Zn is can say this thing's anode or this is cathode? How can you tell? How can you tell? By simply saying you can't tell. By reaction you can't tell now, because both are oxidation reaction. How will you determine which one is anode and cathode? In last class I have discussed these things, that clear-cut explanation you will get by seeing the value of reduction potential. Both are reduction potential. Here you remember, both are reduction potential. Then here, whose value is less, that is anode. Simple things. And whose value is more, that is the cathode. Then cathode minus anode you have to write. E cell is equal to E cathode minus E anode. Then here see which one is less. One is 0.76, other is 0.41 volt. Which one is less? This is less. Both are in positive. Last class I told you which one is lower. That is only an anode. And which one is more? That is a cathode. Then by seeing this value, standard electrode potential, both are reduction value. You have to remember reduction potential. Then this value you can see 0.76 is more, and this value is 0.41 volt is less. It means it is the anode. This is the anode. Iron will function as anode, and this will function as cathode. Then E cathode minus E anode. Then E cathode means 0.76. 0.76. And after that minus E anode. Then minus E, you have written this. Here just for this formula you have written first point this and plus this. But now same things are there. First cathode means 0.76 minus anode. Then minus anode means minus 0.41. Minus 0.41. You have written minus 0.41. Then after that you will get this value 0.35 volt. Correct? Then two method I told you. First, oxidation reduction, both you add, both value you add. Correct? Then you will get, because nothing has been checked. Here only one thing is there, that both should not be the same. Both should not be the oxidation. One should be oxidation, other should be reduction. That why the first method you have changed it. Potential value you have changed, because both are reduction. One you have made as oxidation by changing the value minus. After that you added. This is the first method. Second method I told you the standard method. ER minus EL means E cathode minus E anode means 0.76 minus it is given 0.41. Then you will get the same result. 0.35 volt. This question was asked in 3 examinations. IIT, second examination in medical also this question was asked. And third examination again you can say Punjab CET also it was asked. PMT 3-4 examination. In 3-4 examination this question was asked, because it is a tough question. Okay, it looks easy but it is not easy. Okay, then now next question number 4 I am telling you. This question is also similar to the third question. Here electrode potential, I am reading the question. electrode potential of zinc, Zn means it is actually reduction process. You remember, Zn ion is converting to Zn. Its value is given minus 0.76 volt, and that of copper. Again, you can see reaction. Both are reduction reaction. Zinc is converting to Zn. Copper ion is converting to copper. Both are reduction process. Okay. Then here electrode potential of Zn, zinc electrode Zn to Zn ion to Zn is this minus 0.76 volt, and that of copper ion to copper is plus 0.34 volt. Calculate the EMF. EMF you have to calculate of the cell constructed between these two electrodes. Then now you can see here, there they have given both were oxidation. Here both they have given reduction. See here, reduction. Zinc ion to zinc. Here copper ion to copper. Their potential is given. Then here same concept will be utilized. Means see what you have written same way also you can write oxidation plus reduction. E oxidation means for zinc and for reduction. Then for oxidation, now you have written 0.76. You have changed Zn to Zn ion to Zn. Value was in minus. Now you have written plus. You have reversed it. Correct? And that was okay. That was 0.76. This oxidation value, zinc ion oxide minus, its value was minus 0.76 and copper was 0.34. Then one you have changed, minus you have written plus. That is because this is the reduction process. Then oxidation process reverse it. Plus 0.34, that was already reduction. Copper is already reduction. This only you have changed because it was reduction. You convert it into oxidation. The one became oxidation, other became reduction. And just simply you have added. Minus was there, minus 0.76, now it became 0.76. Both you add, you will get 1.10 volt. This is the first method. Second method also you can apply. ER minus EL means cathode minus E anode. Then here, that how will you think which one is cathode or anode? Then already I told you that by seeing the value you can tell. Then which value is less? Which value is less? Then this value is less and this value is more. Copper is more, plus 0.34. Plus 0.34. This value is more and this value is less, negative value. Then cathode minus anode, E cathode minus E anode. Then first you write 0.34. You have written 0.34. And after that minus, and this is already value is in minus. Then minus will become plus. Correct? Cathode minus anode. Then cathode value is 0.34 minus, in bracket again you write minus minus 0.76 you will write. Then minus become plus. Correct? Then that's why both are in plus. You will add, you will get 1.10 volt. Correct? Here again both method will you can apply which you feel easier. But what I am telling you, E cathode minus E anode, that is very good. Just to find out which one will be anode, which one will be cathode by seeing the formula. By value, seeing the value you can tell it. Okay, after that very easily you can calculate. Last, this question was also actually this same type of question. This question was also asked in some examination, I think 2-3 examinations. Same question. Now last question, today's last question, I am telling you, question number 5. Calculate the EMF of the cell. this is the given the cell. Nickel to nickel ion, and nickel ion concentration is 1.0 m, and auric to auric ion to auric ion concentration is same, 1.0 m. Auric is gold, you know. Then auric ion is converting to auric. Here nickel ion is converting to nickel. Nickel to nickel ion, that is the oxidation process, and this is the reduction process. This is good, correct. Nickel to nickel ion oxidation process, and auric ion to auric, that is the reduction process. And ion is the concentration is same in both cases. And it is given, here it is given a standard E for this process, Ni2 plus to nickel means reduction, Ni2 plus to Ni reduction process. Its value is given minus 0.25 volt, and for auric it is given 1.5 volt. Here you have to think, it is also tricky. It is not so easy. It looks like easy, but it is, you have to think here. It is different type of numericals. Then now actually here same formula we will use. Formula will be the same. Means E cathode minus E anode, or E right side, E right hand side electrode of right hand side electrode minus left hand side electrode. Correct? Potential of right hand electrode minus potential of standard electrode, potential of left hand electrode. Correct? RHS means cathode you are talking about. LHS means anode. Formula is the same, common formula, cathode minus anode. But now here you can see that cell is clear, cell is no problem. Then this is given 1.5 volt. Which one is cathode? Now easily you find out which one is cathode, which one is anode by the value. Then now you can see this is more, 1.5 is more than minus 0.25. In all sense, 0.25 is less. Even it was, suppose it was 0.25, then also it is less. It is minus, then also it is less. Then less is anode, and more is cathode. Then 1.5. First to write, cathode is 1.5 minus. Now we have to trick is there, that here value is given for just the reduction value, nickel to nickel and to nickel, and minus value. Just to reverse it, because you require this value, nickel to nickel ion you want, and it is given a reverse of nickel ion to nickel. Hence this you reverse it by changing the sign. Then you will get in the place of minus you write plus 0.25 and put here in the formula. Then 1.5 minus, now 0.25, minus was there, now you are writing only plus, nothing writing means plus 0.25. Then now after that what you will get? You will, this is the actually already this minus you have to write. Here 1.5 is reduction, this that value 1.5, and here 0.25 values, then a minus. Then here you will get 1.5, that is the reduction potential. That is okay. It was more, and this was no value, write same value, minus 0.025. Correct? Just correct. Here you write not this minus 0.025. You change to the plus. You have to change. And before that in formula minus was there. That's why you written minus. Very simple. 1.5 minus, and this value now you know it become plus. That you have written inside. Simple. Then now here after, but here it is coming 1 minute 1.5. Here nickel ion. Here just you have written E cathode, that is a 1.5, correct, and minus E and minus anode value. Then this was here it will become minus minus plus. Directly this value you put directly, then minus this minus and one more minus was there outside, it became minus minus plus, or you can write like this 1.5 minus directly this value write, this reaction, that value minus 0.25, then minus 1 become plus, and total will become 1.75 volt. Correct? Minus minus plus, it will become, because you have considered compared with volt only, this is the positive cathode, this is the anode. Okay, then here that you have to write minus minus plus, it will be plus, then 1.5 plus 0.25, it will become 1.50, you can write 1.550 also. Then now it will be easy to calculate 7.5. Okay, then now just today I have discussed 5 questions there, but last 3 questions was tricky, and it was asked, this question, last question was also asked in 2 examinations, engineering, Punjab engineering CET and PMT MP. See, then this type of question may be asked in examination also, because it is tricky. Here just for confusion purpose they have written nickel 2 ion plus nickel. You have to just consider by this value. Okay, then you will not face any problem. Here for the confusion given one scope, but value you have to consider. Okay, then now I am stopping only here. Thank you. Now here just you have written E cathode, that is a 1.5, correct, and minus E and minus anode value. Then this was here, it will become minus minus plus. Directly this value you put directly, then minus this minus and one more minus was there outside, it became minus minus plus, or you can write like this 1.5 minus directly this value write, this reaction, that value minus 0.25, then minus 1 become plus, and total will become 1.75 volt. Correct? Minus minus plus, it will become, because you have considered compared with volt only, this is a positive cathode, this is the anode. Okay, then here that you have to write minus minus plus, it will be plus, then 1.5 plus 0.25, it will become 1.50, you can write 1.550 also. Then now it will be easy to calculate 7.5. Okay, then now just today I have discussed 5 questions there, but last 3 questions was tricky, and it was asked, this question, last question was also asked in 2 examinations, engineering, Punjab engineering CET and PMT MP. See, then this type of question may be asked in examination also, because it is tricky. Here just for confusion purpose they have written nickel 2 ion plus nickel. You have to just consider by this value. Okay, then you will not face any problem. Here for the confusion given one scope, but value you have to consider. Okay, then now I am stopping only here. Thank you.